All right, we're gonna solve these problems pretty quickly. So first one, Katie throws a 1.8 kilogram basketball at 55 kilogram cart. Cart slides 0.3 meters before stopping. Mu is 0.6. Friction coefficient. Assuming it's kinetic, simply because we don't have a velocity for different final velocities for the ball and the cart. It seems like there's just one velocity for both at the end. This is a mistake. So what that means is they stick together. So inelastic, that means it's inelastic. So this is the formula for inelastic. Remember, m1v1i plus m2v2i initial is equal to, and since it's elastic, they share the same velocity, m1 plus m2 b final. Okay, so first things first. Okay, cart is stationary, it seems like. So v2 initial is 0. So 0. We need to find v1 initial, which is the ball's speed before impact. Okay. V final is also missing, but we can get that pretty quickly. So, ball, cart, mu is forced this way, ball is forced that way. Okay, we can just have that there. We're going to use the kinetic work principle, which is difference in kinetic energy is equal to the work or net work. Remember, kinetic energy is 1/2 mv squared. Work is force times distance. And since we're looking at the difference in kinetic energy for the final velocity, which is this part of the equation, we can say this guy is the difference right here. So this is the difference in the final velocity, m1 plus m2. So you would use the total equation for this would be, let me move to this, 1/2 m1 plus m2 b final squared equals to force times distance. So here's where it gets tricky. Let me move over here, actually. Let me get rid of that. I'll make it cleaner. Okay. Force times distance. What do we know about coefficient of friction? So force of friction is equal to coefficient of friction, mu, times normal force on the object. Force is equal to ma. So this guy. Mass of the cart times acceleration, which is gravity. Okay. So that's these guys. Bruh. Yeah, that's those guys. Okay. So we have mu. That's just for force, right? So mu times the force, this guy, but remember, m is, since we're looking at the second part of the equation, m is this guy, so because it's the difference. So m1 plus m2 times gravity, and don't forget distance because it's work. So immediately, boom, boom, you can tell that these guys cancel out, so you end up getting, and then you can just move that guy over here. So V final, and remember to square root. So V final is mu 0.6 9.81 times distance. What was distance? 0.3. 0.3, which is equal to, sorry, V final. Just handy dandy calculator real quick. Where you at, bro? You can skip this part because this is just calculations. Yeah. Is 1.329 meters per second. Okay. So we have this, and now we got to do is plug it back into your inelastic equation. So V2I equals, okay, remember this guy? 0. So all we need to do, it's pretty easy, just divide mass. So m1 plus m2 V final over m1. Let's do that real quick. It's equal to, what was m1? 1.8 kilograms. 1.8 times 50. Oh wait, plus 55. 55 times 1.329 divided by 8. Yeah, right? Okay. Is equal to 1.8 plus 55. V final 1.329 over 1.8, which is equal to times 41.9. Hope this is right. It should be. Bro, 9.4. Just review everything. FU force times distance. RGD, K times 2. Oh! Fatal error here. Okay. Bruh. Just gonna erase this. Forgot that too. So 2 times 0.6 times 9.81, 0.3. Let me do that again, sorry. 1.879. All right. So 1.8 plus 55 is 1.879 divided by 1.8. Okay. We get 59.29 meters per second. Right. Yeah. That's it. Okay. Next problem. Eli and Joe shoot 12 kilogram popcorn kernel. I is equal to 2/3 r squared. And I was looking at my notes. Is it rho omega is equal to dr right? V over r. I think so. Let me just double check, actually.
I'll show you real quick. Should be. Yeah. I'm forgetting now. Where are we? You guys can 100% skip this part. This part is going to be trash, because for some reason I forgot. No, it's different. Oh yeah. See? Somewhere around here. Right? No. It's too far. Dude, sorry. Somewhere around here. Oh, right? No. Oh my god. Something I'm looking for.
Oh, okay. Rolling motion. Yes. Rotational motion. I guess V over R. And then, okay. Okay, 12.12 kilogram popcorn using 30 newton meters spring, compressed at 2.5. Rolling down the track above the ground, 1.5 meters. Find its speed at the end of the track. So, boom. 1.5 meters. Ball is equal to 0.12 kilograms. So what we can use here is potential energy is equal to kinetic energy. What do we know about kinetic energy? Okay. We know 1/2. Okay. Let's start with potential. Potential energy, potential gravity. So PE, gravity. And, oh, spring. PE spring. Okay, bro. PE spring. So, PE spring, if you remember Hooke's law, force of spring is equal to kx. This part you really don't need to know because you guys are med students. Integral of kx will give you potential energy. So that is 1/2 kx squared, okay? Equals PES. And then potential energy of gravity we know is mgh. Yeah, gravity. Kinetic energy. Okay. So your total kinetic energy, let's write this, is, was it 1/2 I, is it 1/2 I something? Let me see. 1/2. I have my notes here. Oh, I see. Yes. This is why I needed this. 1/2 I squared, I omega squared, plus 1/2 mv squared. So we know I is 2/3. So K total is equal to, I don't even know why I'm writing that again. Okay. 1/2 2/3 mr squared plus 1/2. Oh wait, hold on. And then omega was, what was it? VR squared. See that? 1/2 mv squared. So okay, that's your kinetic energy side. Well, we can low-key. Let's see. Okay. So you have 2/6. Bro cancels out. Okay. Yeah. 2/6 m. Okay, 2/6 mv squared plus 1/2. Oh, okay. See this. 5/6 mv squared. Okay. This is your total kinetic energy, I guess. Okay. So now we go back to this equation. PE equals KE. So we have your two potential energies, 1/2 K x squared plus mgh is equal to 5/6 mv squared. So all we gotta do is solve this. 1/2. K is your spring constant, so 30 newtons per meter. So 30 newtons per meter. X is distance, 2.5 centimeters. So convert it to meters. Plus height, 1.5. 9.81. H, oh, I'm stupid. 1.5. 0.12 is the mass. Is equal to, whoa. 5/6 mv squared. Yeah, 0.12. Find its speed at the end of the track. Okay. Kinetic energy is the end of the track, so V final. is at the end of the track. So pretty much, you just bring that guy down here, divide it, and then you square root. So B final is equal to, let's see, I'm just doing like this. 1/2 30 0.3 plus, what was it, 0.12, 9.81, height 1.5 over 5, 6, 0.12. So V final is equal to, let's do this real quick, 1/2 times 30 times 0.3. Oh, not 0.3, 0.025. And what the hell is 0.3 from? Oh, that's from the last problem, bro. 0. And yeah, this was squared. Yeah, almost messed that one up. Squared. 0.3 plus 2 times 9.81 times 1.5 divided by 5 times 0.22. Oh, and then you have to square root that, right? Yeah. It's 2.43 meters per second. Is that right? Should be, okay. Yeah, okay. So just to explain again, use potential energy is equal to kinetic energy at 17%. Okay. That, and then you find your potential energies, potential energy of gravity, potential energy of the spring. Potential energy of gravity is this guy. I'm just going to highlight these. Important to know. Yeah. And then this is your answer. Just do that here too. Well, this is your answer. Important to know, this equation. This equation. Yeah, it's also important to know work and friction. Oh my god, sorry, I didn't mean to mark up this much. Yeah, okay. The next one's looked a little easier, I think. Okay. Macy's 240 kilogram cart going west. Georgia's 320 kilogram cart going north. So V final is equal to 2 meters per second at 20 degrees northwest. Okay. Make this look nice. I'm gonna use some bright colors here. So Georgia can be orange, Macy's can be blue. So Macy's going 240 kilograms west. So Macy's is going, actually I can use a thicker one. Macy's is going west. Georgia is going, what did I use? Bro. Orange. Georgia's going north. So north, east, south, west. I gotta make this quick. I don't want my thing to die. Okay. Problem said 20 degrees north of west. So north of west. So west, then 20 degrees north of west. Oh. So that's theta. Okay. We're gonna use a momentum balance, or what do you call it? Momentum equations. So initial, what is momentum? It's P, right? P initial is equal to P final. Highlight as we go. Highlights as we go, important. I'll send this to you guys after, but important. That's the answer. Okay. So we know P final. It's also important to know when they hit both, it's another inelastic problem. So M1 V1 plus M2 V2 initial V final. So it's important to know that once again. Okay. So let's start. West, Macy's is going west. So 240 actually. Let's start with the final. Okay. Sorry about that. Ran out of storage. But okay. Start with P final. No, I literally erased that for a reason. It's P final. Momentum is mass times velocity final. And since they're stuck together, it's okay, M1 plus M2. So this is equal to M1 plus M2, 320 plus 240 times 2 meters per second. Right. Oh, 240. Times 2. Is that 320 plus 1120? Okay. And remember, it's west of north. So we want to find, if we're finding, yeah, okay. So the final velocity going west, because we're trying to find Macy's, right? So we're trying to find Macy's, who's going west. So her final velocity, well, they were both the same, but if we want to find the final velocity in the x direction, broken down into the x, we do, so let's just do P west. or momentum. Cos 20 degrees. P final. It's the final momentum going west. Sorry, I meant we want to find the final momentum going west. So this is equal to oh, 1052.456. Won't be that accurate. I just, for some reason, I like to be accurate. Well, not even I like to, just how we're doing stuff. So P initial for what's her name? Macy is mass times velocity. So 240 times B initial. And remember, P initial is equal to P final. So the P final going west is the P initial going, or Macy's P initial. So it's 240 VI equals 1052.456. So just 240. So V initial for Macy is divided by 240. Oh. Which is 4.8 4.39 meters per second. So that's that. So important equations. Yeah, just I guess these guys. Well, mass times velocity is potential energy. Not potential energy, momentum. So that's that. We have two more. Let's see. This one's pretty easy. Kilograms each, 10.5 meters. How many calories? How many chicken wings? 25%. Okay. Part A, calories. So they both weigh 35 kilograms. Right? Okay. So 35 kilograms, climb 10.5. So potential energy. Yeah. Potential energy of gravity is equal to kinetic energy Alright, okay. So 35 kilograms. So it's just with both, right? So 2 times 35, 9.81, 10.5 is equal to 7,210.35 joules. Every joule, there's every joule is a certain amount of calories, right? How many calories in a joule? Let's be quick. Cal to joule. 4184. Okay. So, right? Wait. so 1 calorie, 1 kilocalorie, what? I need a new kilocalorie. So 1 cal is equal to 4.2 joules. So if we divide by 4.18, get 1,723 calories. Should be. Okay. Yeah, there's 1 kilocalorie. Okay, so 1 calorie. Is that right? 1 calorie is 4.2 joules? Alright, I guess. Alright, so that's part A. Part B. How many chicken wings at 1.8? This is pretty good. Oh, efficiency. Okay. So efficiency is equal to work in, work out. This is important. I guess it's 2. I don't know. This is just your PE equals KE. So 0.25 is equal to 1723 divided by work out. So work out is equal to 6892. If I can write well. Okay, and then 1.8 wings, or 1.8 cal per wing. Bruh. Per wing. So, calories to be 25% efficient. Wait. Yeah, right? How many calories? I think so. Am I doing this right? Yeah. Okay. So to turn this into wings, we just multiply. No, we divide by 1.8. Yeah, 6, 8, 9, 2, 3, 8, 2, 8 wings. Should be right. Just double check. Also, okay. This is from thermodynamics. So, yeah. Whatever. Stephanie, yeah. That's just how I would do in thermo, but it should be the same. Stephanie is 40 kilogram. Warms from 32 to 38. How much 20 water? Mushroom. Pull back down. 4190 specific heat. Okay. Oh, okay. So, if we remember, Q in is equal to Q out for this problem. Should be. Oh no. Stephanie's thermal energy is equal to, should be equal to the thermal energy of the water. So if we remember, Q is equal to MC specific heat delta T. So for Stephanie, it's 40 kilograms. Human body is 3,400. She goes from 38 to 36 is equal to specific heat of water. So we don't know the mass of water that she needs. So mass of water times, what is it? 4190. Should drink to cool back down. How much water? Okay, so she needs to go back to 36. So the difference is 36 and 20. So literally all we do is just divide this guy. And then MW is equal to 4.07 kilograms. Should be kilograms. Okay. Important to know. Thermal energy for both of them should be, we want to make them the same. And that is MC delta T. So for Stephanie, C Stephanie, C water. Yeah, that's how you do that. I'm gonna review it and try to fix it if there's anything wrong, but that should be it. Good luck, guys.